Hey there, this is the week of May 4th. This is the first lesson. This is our acid-base unit. So I'm going to go through the odd-numbered problems with you and kind of show you how to do it. So for this top section, what we're doing is trying to determine whether what is listed is an acid or a base. Okay, acids will have a hydrogen in them. So that's what we're looking for to determine if it's an acid or a base, or if it's an acid. So acids will have hydrogen. Bases will have hydroxide. Okay, so it's an easy way to remember when something is an acid versus when something is a base. So number 1 has that hydrogen, so this is an acid. Number 3, well, look, got another hydrogen right there. That's an acid. And number 5 has that hydrogen. Remember, bases have the hydroxide. Bases have the hydroxide on them. So this would be a base. Number 7, same thing. Look, see we have the hydrogen right there. That means it's a base. And number 9, no hydroxide. It has the hydrogen instead. So that is an acid. Okay. Which ion is produced when an acid dissociates? Well, look here, acids have hydrogen, bases have hydroxide. So when they break apart, it's going to have the hydrogen ion that dissociates. Okay, that's what's going to be produced when an acid dissociates. Helium's just a joke. That's dumb. That doesn't even make sense. Okay, number 13. These are the definitions of acids. There's Arrhenius acids, and there's Bronsted-Lowry acids, Arrhenius bases, and Bronsted-Lowry bases. Bronsted-Lowry widened the definition of what is an acid or a base. Acids, they said, are proton donors. Remember, that proton is nothing more than the hydrogen. So it's something that has a hydrogen that's willing to give up or donate that hydrogen. So that is a Bronsted-Lowry acid. Bronsted-Lowry bases, now these are different. These are defined differently than just the Arrhenius base. Arrhenius bases will give off this hydroxide that we were talking about earlier. For something to be a Bronsted-Lowry base, it has to be something that will accept the hydrogen that the Bronsted-Lowry gives off. So this thing is going to be a proton acceptor. It is going to take that hydrogen or that proton from the Bronsted-Lowry acid. So Bronsted-Lowry base is C. Number 17. Choose the statement that correctly describes a base according to the Bronsted-Lowry definition. Well, remember up here we talked about how Bronsted-Lowry bases are proton acceptors. So when we go back down here to number 17, since we're looking at Bronsted-Lowry, it has to be something that's a proton acceptor. So let's see, bases are electron pair acceptors. Oh, nope, that's a trick right there. Electron pair acceptors, that's a no. Proton donors, nope, that's the Bronsted-Lowry acid, remember. Bases are proton acceptors. Well, there it is. C is the right answer there. C. Bronsted-Lowry bases are proton acceptors. And last one, number 19. Which of the following would be considered an Arrhenius acid? So Arrhenius acids just start with a hydrogen. So find the one that starts with the hydrogen. It's right there. A. Okay, I hope that this was pretty easy for you. Remember that acids will have hydrogens. Bases will have hydroxides. Arrhenius acids will dissociate and give off the hydrogen. Arrhenius bases will dissociate and give off hydroxide. Remember, there's that separate definition of Bronsted-Lowry. Bronsted-Lowry acids are proton donors. They will give up the hydrogen. But the Bronsted-Lowry base is where it gets a little trickier. It doesn't have anything to do with the hydroxide. It has to do with what is something that will accept the proton from the Bronsted-Lowry acid. So, good luck and hope you do good on the quiz.